Great. Great. Okay, well, we're going to go ahead and get started. My name is Pam Bold. I am with the Central California Rural Regional Energy Network, and we're pleased to be presenting this morning on leveraging the energy code for home hardening. I will do a little introduction to what the CCR REN is. If you go ahead and go to the next slide. So the Central California Rural REN was approved by the CPUC, the California Public Utility Commission, in September of 24 with a 24 through 27 budget of $36 million. It is administered by the County of San Luis Obispo that leads all regulatory and reporting requirements for the organization. And we're offering 6 programs primarily designed to serve hard to reach customers in underserved communities, hard to reach in rural communities throughout Central California. There's, if you go to the next slide, please. So here's a map of the region. I actually run the High Sierra Energy Foundation, and for the Eastern Sierra, we represent Inyo and Mono counties. The San Joaquin Valley Clean Energy Organization has the counties within the Central Valley, and then the Central Coast comprised of the County of San Luis Obispo and the Association of Monterey Bay Area Governments. And the County of Ventura is part of the CCR REN in an advisory role only.
But I want to show you this because my sensitive say.
Someone, there we go. So the programs that we currently run are a residential program that offers energy efficiency audits and installation of simple measures that currently is in the San Joaquin Valley and will be rolled out to other regions in the future. That program is aligned with a youth workforce education and training program where youth are trained and then actually do these audits in homes in the region. We have a commercial energy improvement program, which is no-cost electrification projects for commercial customers. And we support public agencies in the Monterey Bay area. And then Codes and Standards is the program that you're participating in today, and that provides training and technical assistance for building professionals. And lastly, a finance program is slated to launch in 2026. So moving on, I will introduce you to the Imbalance Green Consulting firm, and Jennifer Rennick will be presenting today. I encourage you all to ask questions. You can drop them into the chat at any time. We have a pretty small group, so if there's something that's really burning, if you raise your hand, if it fits, we can address that now. And may also just be good to give Jennifer and Tatiana an idea of who is on the call, and so that they can address content particular. If you want to just put your name and either if you're with an AHJ, if your role or what your role is, that might give them a better idea to do any customization or talk to that. So with that, I will go ahead and turn it over to Jennifer.
Everybody, welcome. I'm glad you could make it. And yes, please do put in the chat if you're an architect or if you're on the code enforcement side or general interests. And we do have time for people to put their questions in the chat. And Tatiana, who is here with me from Imbalance Green Consulting as part of the CCR REN Code Coach team, please put that in the chat, and then Tatiana can stop me and ask the question. We are part of the CCR REN Codes and Standards program. So we also do in-person training. We do online training like we're doing now. We can also offer specialty services, such as support for the standards and over-the-counter accessory dwelling units, those kinds of questions that come up with those. And part of our Code Coach is that we answer Title 24 energy and CalGreen questions. So if you are a plans examiner, an inspector, architect, designer, builder, project owner, general public, the Code Coach service is free, and it's available to anyone in the CCR REN regional territories, which, corresponds to those regions that Pam went over. So please use it, reach out to us if you have any questions. You'll fill out a form online is one way to do it. Then our code coach will respond to you in 1 to 2 days. And then we will do a follow-up phone call when requested or needed. And at the end of the slide deck, I'll have the website and kind of reminder of how to reach us through the code coach service. Today, there are learning units available, self-reporting at the moment. In the future, these are they'll be automatically accounted for, but as of this morning, it looked like they might still be self-reporting. We'll follow up with you if that changes. Otherwise, here's your learning objectives, and you will get a copy of the slides at the end, and you can use that to help document that you took the course, and so that you'll get your continuing ed units. Today, we are going to go over a little bit of the historical context and background of how the energy code and building code and fire safety kind of meld, and where we are with that. And then specifically, we're going to dive into a little bit about air sealing, because there's some overall strategies we can use for our walls, roofs, floors, create unvented attics and crawl spaces, all of that to help with the fire safety. We're going to talk a little bit about windows and what's going on with windows and the code as far as energy and fire code. We're going to talk a little bit about roof mounted PV panels, and then we'll spend a bit more time on battery systems, because there has been a lot of kind of change in the energy code and the fire related codes concerning battery energy storage systems, especially the ones that we're using in our homes and in and around our buildings, more and more being required by the energy code, yet they have an implication for how we want to use them to reduce our fire hazard. With the California building standards, they're labeled as 12 parts right now. And as an architect and kind of in an energy code, I use, a lot of these codes extensively, but today we're going to primarily be focused on the energy code. And it overlaps a lot with, of course, the building code and the residential code. It overlaps with all of them, but there's some things specific to fire safety and energy use that are in the residential code and the Part 2 California Building Code. Of course, Part 9 is the California Fire Code, and so we'll talk a bit about that. New to 2025, currently Part 7 is vacant, but there's going to be a new code that's taking place where we've taken parts and pieces from all these other codes and put it into one place, hopefully that helps us really deal with the wildland urban interface code, and specifically for wildland urban interface, we're talking about high fire hazard severity zones. We've been working on our wildland fire safe construction for years. For 20 years, I've been involved with it. Others have too, for much longer than that. And my first exposure to this was back in 2005, and just one demonstration building that was done in collaboration with CAL FIRE was at the Paso Robles Mid-State Fairgrounds. And so this little demonstration building took 4 different wall assemblies, and created each one that would help mitigate or be more fire safe. Same with the 4 roof planes, and it was a slab on grade construction. And what we tried to show is that there were some best practices and some better practices for fire safe building. This was before a lot of these features had been codified, but some of the strategies that were used then that are still really good is to have, for example, non-exposed roof rafters, use non-vented attic assemblies, non-combustion siding and roof assemblies, non-combustion insulation, and the dual paned windows should be tempered. A lot of those features have been included in projects, but then we also learned over the years, for example, on our non-vented attic assemblies and non-vented roof assemblies, better ways of building, which now are actually in the part 2.5 of the code, which we'll touch on in the next few slides. So one of the big things that kind of came out of this is basically to avoid thermal bridging. And you're going to use materials that create thermal barriers. So we want to avoid through framing at decks and balconies, and included like the roof rafters coming out. And so we want to flash with fire rated products. We want to use non-combustible materials like fiberglass reinforced exterior gypsum underlayment at the metal roofs. And we even would use it on the exterior walls, putting it under siding. You could use stucco and cement board as a non-combustible siding. And then we would look at crawl spaces and vented attic construction and avoid the crawl spaces by doing slab on grade was the way we addressed it back then. And we would do our best to minimize large vented attic, although you need a vented attic to meet the other parts of the code. So since then, we have better tools and better products on the market now to vent the attics and crawl spaces. And we've learned that requiring wire mesh of a certain thickness, greater than 1/16 inch diameter of that wire, and to keep those screened openings no greater than 1/8 inch in diameter, did a lot to help stop fire brands, which is the burning embers, and tiny, tiny burning embers from being sucked into these spaces and into our attics and into the crawl spaces. And Vulcan Vent, for example, has come up with some products where they've coated the structure, the matrix that's behind the vents, with an specialized coating that when it reaches a high temperature, it will expand and seal off all of those little openings that allowed for the ventilation. So it essentially creates a firewall. And now we have better fire rated sealants and adhesives. And it's recommended that you use those types of sealants and adhesives when you're installing your fire rated ventilation system. There's also been some improvement for the underlayments for metal roofing. Sheffield Metals has come up with a new product called their titanium underlayment that you can use under a metal roof that you roll out now. But previously, and this is still valid, is you would use a fiber reinforced glass mat or, fiberglass mat type X gypsum product, 5/8 inch, and you could use that under your roof to get a metal roof to get a Class A fire rating, or you could use some of these products on the walls just to add another layer of protection for that thermal bridging. Now, that's kind of sort of this big picture strategy that we were using. to help stop firebrands from lighting your house on fire. So what this would look like is maybe there's wildfire, or maybe somebody else's house is on fire, and pieces of their burning house would be caught up in the winds, and those embers can travel very, very far, and they would land on people's roofs. And even if the roofing product itself was non-combustible, the heat transfer through that product would catch the wood structure and wood structure, like the plywood, the wood framing. It would transfer that heat and start to catch those products on fire without actually having fire go through it. And also those tiny firebrands could get sucked into the attics or sucked into the crawl space. They could also get sucked into the normal kind of what we would think of back then as the normal kind of cracks, crevices, gaps in construction. So where that energy code and where fire safety start to overlap is air sealing. And the energy code got better and better over these years, which meant better insulation and the better installation of the insulation. And that was known as quality insulation installation, so QII. And then HERS raters were introduced into the code as well. And so the HERS raters, which in 2025 is going to be called ECC for Energy Code Compliance Rater, just FYI. So our HERS raters would come out to a home and do the QII inspection. And some of the things they'd look for is, did the insulation meet the R value, the thermal value, and was the house air sealed? The air barrier, kind of air sealing, has been a part of the code, but really it's only been more, I'd say more recently, with the HERS raters going out and really doing on-site verification of the insulation and the air sealing. And this is where the energy code and our fire safety, these two things can be leveraged for each other, because these days folks are more and more concerned with how to keep their house fire safe, and by air sealing all of these gaps and crevices is going to go a long way to also helping with some of the fire safety. And feel free if there's any questions in the chat, or let me know, Tatiana. And if there's anything I missed, Tatiana, just jump in and speak up. So as this conversation's changed for air sealing, we can kind of look at this now in terms of materials, individual materials, or look at it as a whole assembly. And so even though in the code we know, like, oh, a continuous air barrier is needed, and a lot of times people say, okay, my drywall taped sealed, that's my air barrier. Or they might say, okay, I put Tyvek on the outside of the building, but the Tyvek can flap around. It's not really adhered to the rest of the structure. And each of these individual materials may qualify as the continuous air barrier, but it's really the connection between the different materials that are where we need to really be looking for effective airtightness for our energy code, but also for fire safety. So embers, because they can enter in gaps as small as an 1/8 inch wide, it's really critical that we start to seal the places where different materials join each other. Some of the ways we could do that is by foaming the joints between between members. So in this photo on the left, for example, you'll see kind of a reddish pink foaming product between the blocking and some of the studs. When it's that reddish pink color, it's it's a fire rated product, for example. We want to seal the penetrations when ducts or exhaust fans are penetrating the outside of the envelope. That should also be sealed. And we want to avoid creating framing cavities. So again, the picture on the left, this is a local HERS rater that we work with, and he's taking a look at how the insulation was placed in that wall. And what he noted is that the insulation stopped at the bottom of the blocking and didn't go up in behind there and fully fill that cavity. So, again, it's energy code, but it's also better for fire safety that we don't create these empty voids and cavities within the framing of a project. So some of those kind of airtight, quote unquote, hotspots that we look for to really help with the energy code, but also this is going to help with fire safety, is that air barrier on the outside of the building. We like to adhere it to the foundation itself, just below the structural sheathing. And there's a few different ways you could do that. One's with a self-adherent membrane, like the product up at the top photo, or we can use specialized tapes that can stick to both the sheathing or the plywood or the OSB that is on the outside of the studs. You can use a specialized tape that can stick to that and to the foundation. And then there's also some chemically compatible liquid membranes that can be put on with a putty knife. And all those seal that classic gap in most people's, especially older homes. They have a huge gap where the siding, the plywood, the foundation, the sill plate all kind of overlap and don't actually meet or create an air barrier. So we try to eliminate that. Some of the other places, a hot spot is that a lot of times when it comes time to drilling through the structure for conduit or wiring and other electrical and ventilation materials, a lot of times the builder might go in and drill one large hole. And one large hole, putting a lot of wires through it and conduit through it, creates a situation where it's almost impossible to air seal. And a lot of some of these products are having to go to the outside of the envelope and back into the inside of the building. And so then now you've created a situation where there's a lot of gaps. So it's advised to drill individual small holes and then use your fire rated foam sealant and seal each penetration individually. There's also specialized self-adhering membranes you can use, and you can cut it properly to seal around the penetrations, or they even make self-adhering gaskets now for some of those. So that's just one way, like the energy code, trying to improve the energy efficiency overlaps with beneficial features for stopping those air gaps in places where the burning embers can be sucked into your house. Rain screens is something that's come up in the energy code quite a bit. So what we do with what's a rain screen, yes, it protects from the rain, but really the idea here is that we're holding the siding of a house just a little bit off of the wall. So that way, if the siding gets wet, it can dry both to the outside of the house, but also dry to the backside of the siding. The reason for this is we're trying to minimize phenomenon that occurs when siding is pressed up against the wall materials. The water can't quite get out, and the wall materials will absorb that water. So for energy, for longevity, creating rain screens is kind of a better way to build, but there's been some concern that now we're creating an air gap behind our siding. What is that? How does that impact fire? So Vulcan Vent, for example, has come up with a heat sensitive strip vent that you can use at the base of that wall. And if you have a siding type where it is also an air barrier, then you can use that type of vent. And some of the folks from Passive House are experimenting with that. And then we also recommend using non-combustible exterior insulation, or an insulation that isn't going to just quickly catch fire. So rock wool, for example, is a non-combustible exterior continuous insulation product you can use. And we could do whole classes on each one of these things. So for this course, we're trying to keep in mind, we're highlighting the way the architects and the builders can meet the energy code, have improved energy code performance, and also improve their fire resistive construction. So one of the big places that we really kind of are looking for how to improve fire safety, and we get this a lot, is clients want to use unvented attic assemblies. They just want to avoid the ventilation you need for your typical attics, because everyone, quote unquote, everyone knows that that's a place where burning embers can be sucked up into the attic, either through gable vents or, eave vents. And we can create unvented attic assemblies. This is a part kind of construction that overlaps with multiple codes. So we have the Title 24 Part 6 Energy Code, which is telling us what we have to do for our thermal performance. But we also need to meet Title 19 and Title 24 Part 2 for addressing fire safety and the exterior fire exposure. And then, of course, we have Part 2 and Part 2.5 that actually, of the building code, that actually deals with what's allowable for attics and how to ventilate for them. So that's dealing with the longevity and integrity of the building materials and the attic materials themselves, whereas the energy code is saying, you could vent it, you cannot vent it, but if you vent it, or if you don't vent it, we're still going to tell you how much insulation you have to use. And then it's the residential code that dictates what type of insulation and how to vent it. So where these things all overlap is that we're seeing more unvented cathedral rafter assemblies like this, where closed cell spray foam is sprayed on the underside of the roof deck, and then an air permeable cavity insulation is often used, or sometimes now we're seeing that the whole cavity is being filled with spray foam. And then on top of this, which isn't shown, you would have your Class A fire rated roof. So that could be your plywood sheathing with a layer of dense deck and all the other weatherproofing, waterproofing, and a metal roof, for example. The other way we're seeing this, or you could do it per the energy code, is to use continuous exterior insulation on top of the roof deck. or alternatively, you could locate that exterior rigid insulation underneath the roof deck. And again, this would meet your unvented cathedral for building code, for the energy code, but a lot of our clients are really trying to avoid rigid foam insulation up on the roof deck in the first place because of fire. So in order to do that, then we're starting to look at some unvented attic assemblies that you may not be familiar with. And these look like a traditional attic, but the difference is up at the ridge where you, or gable end or ridge vents or dormer vents, they're not really open. We have a fireproof, kind of airtight, watertight, but fireproof vapor open exterior gypsum sheathing known as vapor ports that cover those openings. So if you're on the plans examination side, you might start to see some of these. And the part of the code that really spells out how you're allowed to do this is actually part 2.5 of Title 24 in the residential part of the code. And this vapor diffusion port, what it does is it allows trapped vapor inside the attic to escape. And so it's considered an unvented attic because it doesn't have the openings that let the air from inside and outside just freely pass. It's kind of a semi-conditioned kind of attic where the vapor, which is the part that's the moisture in the air, which is the part that would rot out your roof deck, typically up at the ridge, because moist air is more buoyant than dry air, as it turns out. So moisture, and especially if it's warm moisture, is going to go up to the ridge of your roofs. So this allows the vapor out without rotting the roof, but it's not going to allow fire embers in through those ventilation, what would have been ventilation openings. So this is what you're allowed to do if you have your insulation on the attic floor. And if you are choosing to do a type of insulation installation where that air permeable insulation is up and it's hugged up against the bottom of the roof deck, then you would also have your vapor open, your vapor ports, so they'd be covered with a material that allows vapor to get out but keeps embers and fire from coming in. And you would also have to do a calculation. The architect, would do a calculation and include some supply air. And it's 50 CFM per 1,000 square feet of ceiling area. And a rule of thumb is a 6-inch diameter duct per 1,000 square foot of that ceiling area. So the heating and cooling mechanical system would actually supply air up into the attic. And so you might start to see this where I'm working on a project right now where the homeowner wants to do this and where it gets kind of interesting. So if you're plans examiner side, if you have a really tall attic space, is that attic space really attic or is it part of the living space? Because what you're going to see is supply air duct go into those parts of the area to kind of complete this picture of how to do it. And it's attic space, but you're going to have some supply air. I know this might be a bit confusing. It's kind of new for a lot of people in California to design this way, but this is one way we're seeing that can help with fire hazard areas. So please reach out to us at Code Coach and we're happy to walk you through the whole section of the code and what it means and kind of how to interpret it. For unvented crawl spaces, these two are kind of considered semi-conditioned spaces, and really the two things to keep in mind is that you're going to have a vapor barrier over that exposed earth or grade, and you're going to need that vapor barrier sealed around at the edges. So this is an example of a photo of a retrofit converting an existing home to an unvented crawl space. You do need some kind of mechanical continuous exhaust or mechanical conditioned supply and or supply exhaust with dehumidification. So again, it's kind of a semi-conditioned space, similar to what we're looking at for the attic. In new construction, it's much easier. Before you add that floor, you could get in there and put down that class 1 vapor barrier, and you can use specialized tapes to seal the vapor barrier to the foundation and to itself, and lap your sheets 6 inches minimum and create a space that won't allow vapor drive from the earth up into that space under the crawl space. So, you know, the vapor mitigation is for the longevity of the structure itself. It also helps with your meeting your energy code requirements, and then having an unvented crawl space then further fire hardens your house against you know, embers and hot air coming up into the crawl space and catching your floor on fire. All right, with windows, there's been a bit going on here with windows and the energy code. Right now for energy code, the energy code is going to dictate the thermal performance of the window. And as a reminder, if you all aren't if you're new to this, the U factor is how we rate the windows, and the smaller the U factor, the better the window is against heat transfer. And so just about all brands of windows now have dual pane and triple pane glazings. So under the 2025 energy code that's coming up, these U factors are dropping a bit for certain climate zones. So for climate zone 16 and climate zones 12, 13, 3, 4, 5, all of those climate zones are going to have a slightly smaller U factor for their windows, 0.27. And then the maximum you're allowed to have is a 0.42. And that's just kind of your mandatory maximum. So if you do a computer performance model, you can have windows that don't perform as well as that prescriptive requirement, but you have to show other places in the building that save energy. So it's this mandatory 0.40 maximum now that's got some people a little concerned, because as it turns out, most of the fire rated windows that you might want to use if you're in a high fire hazard zone is 0.42. So it's greater than the maximum. So now you've got to find windows that are meeting the maximum, and you still want to have a well-performing house with good quality windows. So now there is going to be a new exception in the Part 7 of the code for the wildland urban interface, where the U factor windows and skylights installed in a building, if they're located in there, you'll be able to take this exception for that mandatory U factor. So it kind of opens you up to more window brands with this exception. Now, certain window brands are working diligently to come up with fire rated windows that also are better thermally performing. And right now, if you want to learn more about which products in general are meeting these requirements, you'll want to pull the most recent version of the State Fire Marshal listed Wildland Urban Interface Products Handbook. And last time I looked it up, there were just 2 brands of windows that were meeting these requirements. One, the Riviera Bronze for residential construction. It was a thermally broken steel frame that was meeting these requirements. And then there was one brand for the commercial brands, for commercial windows. Long story short, even if you're not going to take that exception, you're wanting to use dual or triple paned windows that have thermally broken frames, typically steel, and tempered glass with the inboard and outboard panes tempered. And if you can't do that, at least, you know, you can do one or the other. And for some of the some brands of windows now, they're offering a dual paned unit that gives you all your thermal performance air sealing, but they're now creating a third outboard pane that is tempered glass. And I was just taking a look at those windows, and I'm seeing that more than one brand now is starting to come out with those. So keep an eye out for that. And I probably mentioned the reason for the tempered glass is because in a high fire, high heat situation, when the glass breaks, you don't want shards of sharp glass everywhere. So the tempered glass is going to break into small pieces. And also, the more panes of glass and the thermally broken steel frames the frames aren't going to melt so readily, and it's just going to slow down the fire. But eventually, windows are a weak link in the whole fire safety. But the idea is to give the occupants more time to get out in case of a fire. So when it comes to solar battery, for high-rise and non-residential structures, we are seeing an expansion under the 2025 code of the occupancy types that are going to be required to have photovoltaics and or batteries. Some of these occupancy types will increase a lot. So for example, restaurants in the past just had under the 2022 current code, just had a small amount of PV required. And now there's going to be quite a bit of PV required for restaurants because of electric ready kitchen requirements. So more going towards more electric and hence more PVs. Also, what we're seeing is that a lot of commercial building types are also being touted as maybe places where people can go in case of extreme weather, like extreme heat. So libraries could be a cooling center for people. And so libraries also are having an expanded PV requirement and battery requirement. And then because of that too, like events, exhibits, certain recreation areas also could be used for cooling centers, those two having a higher PV requirement. So what does this mean in terms of fire and fire safety is that the panels that are on the roof need to meet our fire code. How we access all the equipment on the roof is dictated by our fire code and our building code. And then, of course, structurally, we have to have, the roofs be able to support the equipment plus the firefighters. And we have to make sure the walkways around all of this are clear from trip hazards and obstructions. And that includes the PV system conduit and the raceways, and how we design this with the ridges and the hips or valleys and a juncture to outside parapet walls. All that now is being addressed under the building codes, the fire codes, and all those different parts of Title 24 kind of culminate. So one good thing about the 2025 code coming up is there's a lot more unity and kind of saying the same message in the different parts of the code. So there's more agreement, which makes it easier. Okay. For our non-res and the R3, so R3 is single family homes, but there's a component of the single family homes that can also be used for like caretaker facilities, or long-term care, non-transient housing, that kind of thing. So for part 9, chapter 12, part of the building code, then if it is a residential occupancy, we're going to have 3-foot wide walkways around the PV system. And then the other non-res occupancies, that would go up to 6-foot wide perimeter walkway, and otherwise 4-foot wide for the interior walkways. And then there's some basic things that we would be looking for as designers, but then plans examiners, your fire code enforcement person, they're going to be looking for 4-foot clearances around roof accesses, skylights, smoke hatches, etc. And it's also really important as architects, as designers, that we make sure that we're not showing future location for PV panels located below an egress or an egress pathway. So it just adds another layer, basically another layer of responsibility, but kind of building design integration when we look at our energy systems combined with fire safety and working with our mechanical and electrical engineers. For straight up single family residential construction, so that's part 2.5 of the code, then we're going to typically see 3-foot wide walkways kind of in general, but there are some exceptions now where if you have 33% of PV roof coverage, then you're allowed to have an 18-inch width walkway on either side of a ridge, for example. But if you've got more than 33% of your roof covered with PVs, then you're going to need a 36-inch or 3-foot wide walkway on each side of a ridge. And then there's also some exceptions if the home has qualifying fire sprinklers. So, and again, the PV panels can't be located below, or the future PV panels can't be located below an egress or egress pathway. So some of these things, when it comes to the roof installations of our PV systems, it's fairly straightforward, hasn't changed a whole lot over the years. We just have to be mindful that we don't want the PV system itself to contribute to the hindrance of firefighters or people getting in and out of the building. So for the electrical energy storage battery systems, also called, energy storage systems, ESS, or battery energy storage systems, BESS. You're going to see those words kind of used interchangeably, but what we're talking about specifically for, well, two things. One, more and more folks have portable batteries that are maybe part of a scooter or an e-bike, and those have fire safety hazards. And then, so that's, be mindful of that just as a person who uses buildings, to be really careful what's battery chemistry you have, and to be mindful that your batteries are in good shape. And then there are the stationary batteries that are part of your energy system. And for residential construction, you might be using it for resiliency in case of a power outage. And then for the non-residential occupancies, you might be required to install a battery system as part of the energy package, part of the Title 24 Part 6 Energy Code. And each of these has certain implications with fire safety. Now, the combustible lithium-ion battery chemistries are lithium cobalt oxide, not used so much now. Nickel, cobalt, aluminum, also not used quite as much. But the nickel manganese cobalt was the NMC battery chemistry for a while, was the most common in our home wall mounted batteries. But not all lithium batteries are the same. So typically we'd have that lithium NMC type of battery chemistry. LG Chem was using that chemistry back in the starting in the 2016, and around 2019 it got implicated for starting home fires, and then there was a big recall in 2020 and 2021, and then LG moved away from that battery chemistry. Tesla was used for their Powerwall was using that battery chemistry, but now the Powerwall 3, for example, has moved away from that chemistry. So a lot of brands now are moving towards the lithium iron phosphate chemistry, which is non-combustible. It also has a high power density, and it's cobalt free. So that's good news. And same with the lithium oxide, titanium titaniate oxide. Sorry, tongue twisted on that. Also non-combustible and cobalt free. So that's kind of the good news of when you're buying batteries now. Then existing batteries are still out there, so you got to be mindful, but the new battery chemistry is shifting. And then FYI, on the horizon in the US is sodium ion batteries that are coming into play, also non-combustible. And a lot of the materials in the sodium ion batteries are readily available. Same with some zinc ion batteries, also non-combustible. The difference with these two battery types right now is that they have a lower power density than the lithium ion type. But if they're just sitting there at your house, it's not such a big deal if the power density isn't as high, and it's probably a lot better that they're non-combustible and a little more environmentally friendly. Now, the battery chemistry does dictate the allowable battery size. So currently, under the 2022 code, they don't differentiate. That's just all lithium ion batteries. Each of those units can only be 20 kWh, 20 kilowatt hour rated energy capacity per battery. And then you can kind of have larger size batteries, they're allowed with hazard mitigation analysis. So that's what we're looking at for, say, a multifamily housing project that wants to use batteries. Then we're going to be moving towards a hazard mitigation analysis. With the 2025 code update, this table's now been expanded with some of these new battery chemistries that are coming out. So our lithium ion batteries still 20 kilowatt hour. Each battery bank can only be that size. And so all the home batteries you're going to buy anyway, they're already packaged up and encased and modular to be smaller than that. So you don't really have to think about it too much, but that's why they are the size they are, is to meet some of these code requirements. But with the new sodium and zinc battery chemistries coming on board, they have that ability now to make these into larger sized units because it's reflecting the new battery chemistries that are coming on board. So that'll be in the code that takes effect January 1st, 2026. If you're working on large scale battery energy storage, you will have a hazard mitigation plan requirement. So this is something to, if you're on the plans examination side, this is where a lot of these things are going to be spelled out by the battery consultant. In like a multifamily project we're working on now, for example, Climate Zone 3, it's more towards the coast of our CCR REN region. That battery consultant is working with the architect and the other engineers and the energy consultants to pull together the whole plan, show where the batteries are going to be located. They are using weatherproof self-contained units with fire suppression, for example. And also we're going to make sure that there's clearances from the other structures. So that's typically, the code requirement is typically 10 feet. And there's got to be clearances above, behind it, the front and side to side, and also just the ability to access these. And of course, you have to protect them from fire protection, from vehicles. So there's bollards that will be in place. And in the code, there are very specific additional requirements for rooftop and open parking garage installations. So for example, if you're putting batteries in open parking garage installation, you also have to make sure you have 50 feet distance between your batteries and your HVAC inlet air intake systems. And that can be reduced to 25 feet with some other precautionary measures. So an example of the size of this, just to give you an idea, is there a lot of them are around 7 feet tall. Many of them are 6 feet wide, although I've seen some as narrow as 4 feet and some, even wider than 6 feet. But these are standalone, self-contained, all the electronics and the batteries are all built in, but you do need access in front of the unit because these doors open on the front, and you also have a set of double doors that open typically on the back. And then there are requirements for how close these units can be to each other based on their chemistry. So a lot of that's changing under 2025 code, where they're taking the battery chemistries into play and then also just spelling out a little bit more about what that needs to look like. So currently, the code is actually calling out what you have to put on the construction documents for batteries. So I put this in here too for architects, but also for folks who are just interested to know really what goes into the plans and how our fire safety and our energy code are overlapping, and they're working together on this. So, you know, kind of the main takeaway from this is, yes, you have to have construction documents that show the location, the layout, the rated assemblies, the type, the manufacturer specifications, the details on your fire suppression and your thermal management, the ventilation, and if the systems need exhaust or special kind of venting. And then there has to be a commissioning plan with it and a decommissioning plan so that we know what the end of the life is going to be for the batteries. And then in the 2025 code update, they've now included item number 11, a fire safety and evacuation plan that's in accordance with the fire code. So all that now when you have the batteries. For the small scale battery system. So small scale meaning like each battery unit's less than the 20 kilowatt hour size, typical of the lithium ion batteries. You can have them indoors or outdoors. They can be ground mounted, wall mounted. You do need to protect them from damage. You're going to want to place them where they're protected from temperature extremes. Although with the new lithium and other battery chemistries, that's not quite as critical, but it's still a good idea to protect from climate extremes and adverse weather. And then generally, if it's a 3 foot, like under the residential code, I mean, if it's under the residential code, you need 3 foot separation for paths of travels, 3 feet from the doors and windows. But otherwise, for your other residential occupancies, multifamily and non-res, you're going to want to have 5 foot distance between the path of travel, doors and windows, and your batteries. And then the batteries themselves can typically be separated only 3 feet from each other, but they can be closer together if that authority having jurisdiction says, yes, the battery system meets the proper fire testing and the battery manufacturer specified their minimum distance. So they can be closer than 3 feet. So right now under the energy code, even though each of the individual units would be a 20 kilowatt hour sized battery, you can't, in the aggregate, you can't have altogether more than 80 kilowatt hours on an exterior wall or in your outdoor installation. So if you had, you know, a unit approaching that size, the 20 kilowatt hour, you could only have 4 batteries altogether. So some homes, they do want a lot of batteries. Others are not installing that much, but there is a limit. And that's all for part of the fire safety. You know, that was the idea. It also dictates that if you do have that battery inside in a utility closet or inside your storage space, that you, or in your garage, you have to have 5/8 inch gypsum type X for the ceilings and the walls, all part of like the fire safety. That's how we build a residential garage. You would use that type of type X 5/8 inch at the walls, ceiling anyway. And so now the utility closet or that space for the batteries would also have that type of construction. What's going to be a little bit different coming up on the new code is some of these values are going to change slightly. And I'll show you a slide after that, after this coming up. The other thing is that there are certain rules and regulations about the interconnected smoke alarms that should be installed throughout the dwelling and attached garage. when you have batteries inside those spaces. So what we're seeing is more and more people are just installing the batteries outside and keeping it very simple that way. Okay, new code is going to be referencing our section instead of section 328. It just R for residential 330. They've changed the numbers a little bit to make it a little easier to follow in the logical order for chapter 3 of part 2.5. Okay, so 80 kilowatt hour on exterior wall aggregate. That's the same for garages, detached accessory structures, but now under the 2024 supplemental and the 2025 code update, those things have gotten larger. So now if you're on or within 3 feet of exterior walls, deli garage, you can go up to 100 kWh in aggregate rating. And then there's something interesting here where they're saying, okay, but if you use exterior walls and eaves that are constructed with non-combustible surfaces, and then they define non-combustible surfaces and the dimensions and the measurements of how far that non-combustible surface has to extend beyond your battery, then you can double your maximum aggregate rating on top of that. So you're up to 200 kilowatt hours. So really kind of the big takeaway here is the code is realizing that if you do things to mitigate for fire, you can have more battery storage allowable on site. And then the same kind of thing where the maximum aggregate now is going up to 600 kWh, kilowatt hour capacity. And then you would meet these kind of requirements of distance from property lines and distance from other dwellings. And then also new to the code is additional information. If you do install the batteries near and around vehicles where vehicles could be, then there's additional requirements, because it turns out that especially with some of the older lithium ion battery chemistries, impact can cause the batteries to burst into flames. So keeping safe from vehicles is a major concern. And so there's these additional requirements that you should read up on, especially if you're an architect and you're trying to design for the battery to be located in and around vehicles. What we're seeing commonly is a lot of the designers that we're working with, they're just avoiding it altogether and putting it on the outside of walls, away from cars, using non-combustible exterior wall and eave materials anyway, and calling it good. And so that's probably the most straightforward way, but it's not always an option, like for our multifamily projects. And then, oh, go ahead. Did someone have a question?
There was one question that came in asking if there are any exceptions with fire sprinklers in the garage for batteries.
There's fire suppression requirements for garages and enclosed structures, but it doesn't give you exceptions to like not mitigate for car impact, for example, you know, and also it doesn't mitigate that you would still want to use your 5/8 inch type X gypsum construction. But what it changes, if I'm recalling correctly, is some of the other requirements for distance between certain objects in the batteries. But that's a good question, and I can look it up more, and we can probably dig into it a little bit after we're done. We'll have a little bit more time. This is a picture, just example of an exterior installation. Like I was saying, a lot of the projects we see are just, they're non-combustible siding. They're using the separation between the batteries under the current code. So 3 feet unless otherwise noted by the authority having jurisdiction. This gives you an idea of what all that looks like with your power wall, the inverters coming from the PV system. You'll have a home load center or a disconnect that's within sight of the batteries. So you can shut the whole system down. And then the other components that go along with the typical installation is a gateway, or, you know, it depends on the brand. Sometimes they'll refer to it as their gateway, but it's a transfer of the isolation equipment. The purpose is to isolate the building from the electrical grid during a power outage. So that goes in between your batteries and then your electric panels. And then what you're going to see by code for residential is you would have a 225 amp main panel, because that's what's required now. And then you would have a sub panel that has your backup loads. And right now, the energy code dictates that that backup panel would have 4 branch circuits at a minimum. And in this case, in this particular case, the whole house is backed up. So the panel's a little relatively large, but it could be a smaller panel with only the 4 branch circuits. And it's dictated in the code what those 4 branch circuits would monitor. And that way the home has greater resiliency. And then under the energy code, you could get, if it's new construction, you get extra credit on your performance report. Okay.
We
So,
had,
oh yeah, go
sorry.
ahead. No, go.
We had another question come in. I just got 2 Powerwall 3s and wasn't required to have them mounted 3 feet apart. Is that because the 3s are non-combustible?
Yeah, the new Powerwall 3s are the lithium iron phosphate chemistry, so non-combustible. So yeah, the Powerwall 3s have moved to that battery chemistry. And a lot of the battery manufacturers are moving away from the combustible chemistry. Yeah. And then someone said, oh yeah, it was manufacturer specification, right? Because there were certain batteries also where they proved via the requirements of the fire code and high fire situation that when their batteries were together, that they could be closer together and not causing one battery to catch the other battery on fire. So then your authority having jurisdiction could agree that they could be closer together. Now, if you're, I threw this slide in here as a resource because even though we were talking about home hardening, I thought it was really be a useful tool, especially if any of you are also involved with permitting in your jurisdictions for large scale battery energy storage systems, because the California Business and Economic Development has their Go Biz Clean Energy Permitting Initiative, which was creating a toolkit and an ordinance and guidebook for battery energy storage systems and permitting. And they have one for also for wind energy and for other green kind of green energy systems. But you could take a look at this if this is of interest to you. And I think you have a couple of more days left for the public period to give feedback on it. But otherwise, this guidebook will round out the comment period, and then it's supposed to be published here, I think, in another month. And it kind of goes through, gives you a lot of, even for the smaller scale battery systems, it gives you a lot of great information in one place, like the acronyms that are used when you talk about batteries, and how a lot of what we talked about with the chemistry and the fire code and the permitting and where it overlaps, and just a better understanding of where California is going. Also with big picture, having large scale battery systems to have a cleaner and more resilient electric grid. And if you just want to know more about Title 24 in general, in terms of reading up on all the parts of it, and you don't have a paper copy in your hand, and you want to start getting familiar with the 2025 code, that'll come into play January 1st, you can follow the link at dgs.ca.gov and take a look at all the new codes coming out. And then if you have any questions about the Cal Green and the energy code and how these things overlap, we recommend you visit ccrren.org for the codes and standards programs. Click on the program section. That's going to pull you up where you can enter the part of the website for the energy code coach, and then you can complete our intake form, and that's what that looks like. And then we will get back to you and help you work through your code coach questions. And then last but not least, we have couple more upcoming events. I'll let Pam touch on that. And then we can round out, and we have some time for some questions.
Great. Yeah. So on October 21st, 9:30 to 11, we have the Introduction to Zero Net Carbon Design. We're running that one again. And at that course, the AIA continuing education should be able to get certificates for that. And then we also have heat pump water heaters in the current and upcoming energy code on November 5th from 2 to 3:30. And yeah, we would love to hear from you all, just if there are other topics that you're interested in. I know we're working on a home builder series for the 2026 trainings that we have upcoming. But if there are any specifics that you're interested in, or if you are at a jurisdiction and you would love an in-person training, if you're within that, we actually have 96 AHJs in the CCR territory. That's a lot, but our team is, willing to come out if there's something of interest, or if you have a couple of AHJs that you want to get together to host a training. We're certainly open to that. So reach out to us at info@ccrren.org with any of that. And I know we do have a question. It's important for us to be able to report these metrics back to the California Public Utility Commission. So Tatiana, do we have a couple of polls? We'd love it if you could take those polls now, and then we'll also have a survey that we'll drop into the chat box. But if anyone has any questions, this would be a great time to tap into Jennifer and Tatiana's experience.
Yeah, we have a small group. Feel free to unmute yourself if you have the control. if you can unmute yourself, feel free to unmute yourself and ask a question.
Okay, they may have been taking the poll, but
That's fine. Yeah.
Yeah. Yeah, so curious if there were any, any additional questions, or maybe if you learned something that you didn't really know. I was pleased to hear, some about that fire mitigation around, the best systems. I didn't really know of that. And then I always try to think of the things, I see the things that, are in new code and that are not in my house. So I always have a tick list of things. Oh, yeah, that might be something to address in the future as well.
Oh yeah, this is a good question from Crystal. Just asking, which of some of those methods could be used in a retrofit of an old home. Seems like most of these are for new homes. If you have a crawl space in your old home right now, that's when we are seeing that converting the crawl space to an unvented crawl space. We are seeing a lot in both. I first started to see it for the energy code, especially in the climate zone 16 regions. And it also makes sense from a fire safety perspective. But what it does mean is that the crawl space does need to be sufficiently large enough so that a person can get in there and work. But what they would do is take the vapor barrier materials and get under there and lay it out on the floor of your crawl space and use the specialized tapes and mastics to seal it to your foundation. So someone is going to be under your house. And so that's probably the trickiest part of it. But I know a number of folks who've been doing that, and up in especially climate zone 16, 12, 13, 14, those areas seem to be and even climate zone 5 and 3 are benefiting from it. And so you could take care of both those at the same time. And then we have seen situations where they have converted their attics to the non-vented attic type, but that takes a little bit more work to do that. However, air sealing can be done even on an old house where you can go up into an attic space and take a look at it depends on the age of the house. Like if you really have, if it's really old and it's like asbestos or, knob and wiring type of old house, then you're going to need some specialized help in dealing with that. But if it's an old home, like it was built in the 70s, you can get up there and do a much better job typically of air sealing the attic floor just between the space. And the reason that it helps with the energy code, but it also does help with just the spread of fire, because a lot of times if one space, what some of the latest fire testing is showing is that even keeping a bedroom door closed can slow down the fire and fire spread into that bedroom. And you can use solid core doors. And so what you're trying to do for these older homes especially is create a situation where you have more time to get out. So air sealing around the penetrations that go from the house up into your attic can help slow that down. And then you would do that with fire rated foam. And then you can also have a better chance to upgrade your insulation at the same time for just better overall energy performance. So they both hand in hand. Anything?
Yeah, Jennifer, on that, some of the houses in our region have some radon exposure. I'm wondering if that crawl space, if you're doing that, does it potentially have the co-benefit of some radon mitigation? Do you know?
It can, it does. So if you are in an area also where you're dealing with radon, then you're going to have some other things that you would do like in addition to it. So there's you want to, yes, do everything I just mentioned, but you're also going to be implementing additional things that would collect the radon and take the radon up and above and away from your house. And it can be done with specialized venting, which means having a way to collect it under that vapor barrier and then taking it. And sometimes because it's a remodel, you might have to create an exterior kind of a chimney type of small chimney chase because you want to let the radon up about 3 feet above your roof and have the wind take it away from you.
Yeah, okay. And I know just on the passive house design, that's, is going to be looked at, for new code cycle. And I know that, they kind of frame that also as more smoke tight, really tight envelope. And so moving forward, we may, because certainly in lots of regions, we have severe smoke impacts, even if it's, not fire specific.
Oh, that's right. And then we didn't even, right. So we were talking about home hardening, quote unquote, but yes, airtight house means the wildfire smoke, bad smoke air days, you're not pulling as much smoke into your house. And also, you want to set up your ventilation system for your house. So ventilate for fresh outside air, but you want to be able to turn it off when you have poor outdoor air quality. So that's also part of it, is having greater control over the ventilation when the air quality is good. And then when it's not good, having the ability to turn it off and to have a house that's airtight until that event passes. And you can start to do some of those things on old houses also.
Great. So if there are no more questions, just wanted to let you know that we will be sending you the slides and the survey and link to the recording in your email in the next few days. All of the resources are available from past trainings on the ccrren.org website. So please feel free to go and use those resources. And with that, if there are no other questions, thank you for your time. We appreciate you joining us.
Thanks, everyone.
Bye.